Welcome to Minute Profinet. In today's video, I will explain one of the most dramatic evolutions in industrial automation, the transition from 4 to 20 milliamps to digital field buses. We will compare the two and highlight key benefits and new business models that arise from the use of field buses. For those of you new to the channel, welcome. My name is Michael Bown, and I'm a part of Profibus Profinet North America, a nonprofit member-supported organization. We aim to promote and educate the public on industrial automation and networking technologies. So, if you like learning about manufacturing and automation, please feel free to subscribe to our channel. But for now, let's go to the whiteboard.
What are the differences between 4 to 20 milliamps and digital field buses? How and when did the transition occur? The factory floor has evolved dramatically over the years. The first manufacturing facilities did not rely on any automated controls. All processes were based on manual operation. The first automated controls were pneumatic. Pneumatic pressure controls move pressurized or compressed air signals from a controller to a device through copper or plastic tubes. After the adoption of pneumatic controls, electronic controls were introduced. The 4 to 20 milliamp convention was born in the 1950s as electronics became cheaper and the reliability met the automation industry's requirements. 4 to 20 milliamps provided a low-cost, easy-to-use solution not subject to major signal line losses. Automation logic was accomplished using relays until being replaced by PLCs running relay ladder logic in code. The invention of the first PLC in 1968 simplified automation networks substantially and reduced hardware requirements. In the 80s and 90s, several organizations and device manufacturers started engineering the first field buses, like, for example, Profibus. Field buses enabled two-way digital communication. In a field bus network, the devices are an integral part of the system. From the engineer's point of view, there is no distinction between the devices and the control system. It is an integrated whole. But why was the transition from 4 to 20 milliamps to field buses made? 4 to 20 milliamps has some limitations and disadvantages when compared to field buses. Here's an example of a 4 to 20 milliamp application with one controller and field devices. Each analog signal indicates a precise value for temperature, pressure, or voltage, for example. The values are exact and infinite between 4 and 20 milliamps. But there are some challenges with this. For example, individual cables and wires are required for each device. Troubleshooting can be slow due to the lack of diagnostic information. And signals are prone to unwanted noise interference. Analog signals require wiring from the controller to each device. The wiring costs for a complete project can be costly. Also, it can be challenging to commission and maintain complex and extensive cable infrastructures. Troubleshooting can also be a difficult task with 4 to 20 milliamps. Analog connections do not provide extensive diagnostic information. Some devices might have diagnostic capabilities, but might not be comprehensive. Electrical equipment on the factory floor produces electrical noise. Analog signals are more susceptible to interference, which can affect process accuracy and reliability. Using twisted shielded cables can lower the effects of noise on electrical signals, but it is not a bulletproof solution, nor is it cost effective. For any number of reasons, some automation facilities still rely solely on 4 to 20 milliamp signaling, but many network installations have migrated to digital field buses due to the value propositions. Field buses offer additional functionality and tackle many limitations of 4 to 20 milliamp communication. An essential advantage of field buses is connecting multiple field devices over a single cable or bus. In field bus networks, distributed I/O mechanisms collect or distribute multiple inputs and outputs from the field into a local I/O device. Then, the data is transferred through just one cable to and from the PLC. This factor alone can significantly cut engineering, installation, commissioning, and maintenance costs. Digital signals can carry more information per second than analog signals. They can provide diagnostic information for all of the devices in the network. That information is not only useful to resolve downtime situations, but also prevent them. Network diagnostic information is used for preventative and predictive maintenance practices and other advanced asset management techniques. Signal noise can interfere with both analog and digital signals. However, the amount of noise necessary to affect a digital signal is much higher. Digital field buses can withstand higher exposure to electrical noise without compromising data and communication quality. Modern automation facilities require the speed, accuracy, and versatility of field buses. The greater accuracy of digital means significant improvements in production speeds and quality. Field buses deliver real-time performance for automation environments. And with the shift from analog to digital, we now have a network, and different topologies are possible. Each field bus standard offers specific characteristics. Profibus was introduced in the early 90s by PI. Currently, it is the leading field bus technology in terms of functionality and adoption. By 2019, there were over 62 million Profibus nodes installed worldwide. Today, the trend continues with industrial Ethernet standards such as Profinet. Higher bandwidth, larger message sizes, and address spaces are some benefits. Plus, multi-protocol coexistence enables modern network architectures and connections to higher level systems.
I hope you found this information helpful. To learn more about field buses and Profibus specifically, we've created a detailed slide set with technical diagrams and descriptions. You can download it for free by following the link in the description of this video. Also, please visit our website at us.profinet.com to learn more about the Profibus and Profinet technologies. Feel free to comment below, share your feedback, and ask any questions. And as always, thank you for watching.